Welcome to part 7 of the CompTIA Network Plus for Medical Devices series. In this session, we'll explore distribution systems, the backbone of healthcare networking. Distribution systems link core networking gear with access layers, ensuring that devices like ventilators, electrosurgical units, and imaging systems communicate seamlessly. In hospitals, this means more than just speed. It's about reliability, redundancy, and patient safety. We'll cover both the physical aspects, like structured cabling and switches, and logical aspects like VLANs and traffic segmentation. By the end, you'll understand why distribution systems are critical in bridging high performance core networks with bedside medical technology. This knowledge is key for biomedical engineers and IT staff working together to maintain safe and efficient clinical environments. So, why do distribution systems matter so much in medical device networking? Imagine a ventilator losing connectivity during a patient's critical procedure, or an electrosurgical unit failing to communicate alarms across the systems. Distribution ensures that these connections remain stable, redundant, and secure. It acts as the middleman between the high-capacity core network and the access layers where devices physically connect. In healthcare, even a few seconds of lost connectivity can have life or death consequences. That's why distribution networks prioritize uptime, intelligent traffic handling, and redundancy. In this lecture, we'll connect these networking concepts directly to clinical outcomes so you can see why they're more than just IT jargon. They're vital for patient safety. The core components of a distribution system typically include distribution switches, patch panels, and structured cabling systems. Distribution switches aggregate connections from access switches, providing the pathway towards the core network. Patch panels help with cable organization and maintenance, making it easier to manage the complex wiring in hospitals. Structured cabling standards ensure uniformity and reliability, especially when integrating diverse medical devices. Together, these components form a stable foundation where biomedical engineers can rely on consistent network performance. Understanding these parts is crucial not only for IT professionals, but also for clinical engineers who need to troubleshoot or validate connections between life support equipment and the hospital's IT backbone. When we talk about physical distribution, we're referring to how devices and switches are physically connected. In hospitals, this usually means star or hierarchical topologies, Ethernet cabling, often Cat6 or higher, and fiber optics are common choices depending on the bandwidth and distance requirements. Proper cable management is vital, not just for neatness, but for safety and maintenance. In healthcare environments, tangled cables can delay critical interventions or complicate servicing. By organizing physical layouts, biomedical engineers and IT staff ensure that the infrastructure supports both clinical workflows and technical reliability. This slide highlights how distribution isn't just an IT concept, it plays a very practical role in the hospital's day-to-day operations. Logical distribution goes beyond the wires. It's about how traffic is segmented and prioritized. VLANs are often used to isolate different categories of devices, such as separating life support systems from administrative computers. IP addressing schemes are carefully designed so that devices can be identified, managed, and secured. Traffic prioritization, often through quality of service, ensures critical data like ventilator alarms takes priority over non-urgent traffic like email. In medical environments, logical distribution strategies are essential for both cybersecurity and patient safety. By understanding these logical structures, you'll see how network engineers ensure smooth and secure communication across a wide variety of devices without interference or data loss. Medical device integration brings a unique layer of complexity. Devices such as ventilators, electrosurgical units, infusion pumps, and surgical navigation systems must all communicate reliably. Distribution systems make this integration possible by providing stable pathways and redundancy. For example, a dual home ventilator may connect to two switches for failover, ensuring uninterrupted connectivity. Standards like IEC 80001 and compliance requirements like HIPAA add additional layers of responsibility, ensuring safety and data security. This integration highlights how distribution networks aren't just technical, they directly influence patient care quality. Biomedical engineers need to understand these principles to collaborate effectively with IT staff and ensure devices function as intended in a clinical environment. Of course, distribution systems face challenges. Signal interference from hospital equipment can degrade performance. Medical devices may require electrical isolation or shielding, complicating network design. The demand for high availability in hospitals is relentless. Downtime isn't acceptable when patients' lives depend on the system. Additionally, balancing cybersecurity with accessibility is a constant challenge. For example, isolating a device for security may also hinder its usability if not designed properly. By anticipating these challenges, engineers can design distribution systems that meet the unique requirements of healthcare, blending reliability, safety, and compliance into the network infrastructure. This awareness helps engineers create resilient solutions for real-world clinical settings. Best practices in distribution systems start with redundancy, using multiple paths so that if one link fails, another keeps the system alive. Clear labeling and thorough documentation are also essential, especially in large hospitals where many people work on the same systems. Regular testing and validation ensure that the redundancy works when needed, not just in theory. For biomedical engineers, adopting these practices means fewer surprises during critical situations. This slide emphasizes that best practices are about building trust that devices will communicate, that alarms will sound, and that care teams will always have the data they need. Good engineering here literally supports good medicine. Looking ahead, distribution systems are evolving with technologies like software-defined networking, which allows more flexibility and automation in managing traffic. The Internet of Medical Things continues to grow, adding more devices that need secure and reliable communications. Cybersecurity frameworks are becoming even more important as hospitals face increasing digital threats. For biomedical engineers, this means that understanding distribution systems isn't just about today's hospital networks, it's about preparing for tomorrow's connected healthcare ecosystems. By embracing these future trends, engineers and IT staff can work together to ensure that hospital networks remain safe, efficient, and ready to support advancing medical technology. To wrap up, distribution systems are the backbone of medical device networks, linking the reliability of IT infrastructure directly to patient safety. We've covered the physical and logical aspects, integration challenges, best practices, and the exciting future outlook. For biomedical engineers and IT professionals alike, mastering this layer of the network is critical for ensuring safe, secure, and seamless device operation in healthcare. As you continue this series, keep in mind how each layer builds on the next. Distribution isn't just cables and switches, it's the infrastructure that keeps healthcare connected. Stay tuned for part 8, where we'll dive deeper into advanced networking concepts.